Good morning, everyone. Welcome to another episode of XahTV Show. Today we are going to do coding. Okay, lots of coding. We are going to do find and replace or Unix grep and set in Wolfram language, Emacs Lisp, Golang, Python, Perl, and PowerShell. So I'm going to demonstrate a find and replace code in all these languages, but mostly we are going to code Wolfram language live to write a find and replace script. So video check, audio check, so let's get ready and ready to go. So good morning, Alan. Alan is back, and good morning, Huang. So if you have questions, ask me, okay? Tag me and ask me. So let's begin. So today's, I think it's pretty fairly technical. FF Stray. Good morning. So okay, so let's do this. Bart, good morning, Bart. Finally, you back. Okay, so we are going to, let's do let's do technical. Okay, so on the pink window, I'm using XahFly keys, and this is my keyboard, Kinesis Advantage 2 and Ultimate Hacking. And you can see, you just go search for XahLi keyboard blog, and you can see the reviews and names of all my keyboards. Okay, you go then buy it from my Amazon. I highly recommend. Okay, so that's my keyboard. So we are going to do coding. So let's start now, okay? No nonsense coding. So this is a continuation of yesterday's video. Yesterday we started to talk about find and replace and grep, So okay. So first of all, let me show you. So let's demo. Okay. So go to Emacs blog. Go to my Emacs blog. You can see in this directory, Ergo Emacs. Okay, let's turn on global highline mode so you can see where is my cursor. Okay, and on the pink window you can see all my Emacs command calls. As I, for example, I move cursor, you can see all the commands and keystrokes. It'll show up there in the pink window. And also, I'm using a Vorak keyboard layout. Okay, so in this directory, you can see in this directory, web Ergo Emacs, there are. So we did part of this yesterday, but let's it'll get interesting. Okay, so here is the PowerShell recurse include. Let's see how many HTML files are there. Okay, so here is all the HTML files in this directory, and now let's count. Pipe it to measure. So there are 2,500 HTML files in this directory. Okay, so now let's start to do find and replace. So first stop, I'm going to show you Emacs Lisp. So this is an Emacs Lisp package. So I'm just gonna do it. Okay, so call the command. Okay, the command name is called XAH find. XAH find replace text. We are not going to use regular expression in this case. There's also a regular expression version, but let's just do this. XAH find replace. Okay, call it. Let's replace all the word Haskell by the word Emacs Lisp. You can see at the bottom. Okay, and it asks you which directory. So Ergo Emacs directory. That's correct. And it asks you a regular expression for file path to filter file path. So you want to say .html $, that's all HTML files, file names ending in HTML. Okay, so it asks you the depth. So XAH find, this Emacs Lisp command has a feature that lets you do find and replace only on a specific depth of directory, a range of it. So starting from 0 and all the way to depth 9. Okay, and write change to file, no. Fixed case in search, yes. Fixed case in replacement, yes. Make backup, yes. Okay, now it's running. It's the most time spent is actually the disk speed is the bottleneck, and I have a flash drive. I have a how they call it, solid state drive. So it's much faster than before. So anyway, so here is the result. You can see the pink lines are files that contains the word Haskell, and each of the yellow highlight is the occurrence. So we can enter and jump to the file. So you can see. So let's jump to the first one. Okay. So press arrow key or tab to go to, you can press arrow, or I prefer right arrow, previous arrow, left arrow to jump among the occurrences. So the first occurrence is this one under this file. So okay, so you just press enter, it'll jump to the file. So here's the file shown in browser. You can see there is a word Haskell there. So that's one occurrence. Now this is the file in browser, and let's just search for John. So there it is. So that's the occurrence of Haskell. And remember, we want to replace all the word Haskell with the word eMAC-Lisp. So it didn't happen because we said, write to file. No, we just want to see what happens. So you see, so here is, so that's a demonstration of the eMAC-Lisp version code for find and replace. Very powerful, very convenient, fantastic. I recommend you, if you like it, buy my software. Okay, so let me show you where that is. Describe key, press the key. So here is the source code for XahFind in eMAC-Lisp. So there is 700 lines of code, and here is the home page. So go to it, show in browser. So this is the Emacs find replace in pure eMAC-Lisp. Okay, so you like it, pay me. Okay, I send it to you. So that's eMAC-Lisp version. Now let's demonstrate some other versions. But so far we can see, you can see what what files it found, and let's use this example to demonstrate Perl version, Golang version, Python version, PowerShell version. Okay, so first, okay, let's do that. So close that, close that, close that, close that. Let's go to today's talk show. Open. So here's today's talk show. We demonstrated find replace in eMAC-Lisp. Now let's demonstrate PowerShell. Okay, so go to PowerShell. So current directory, if you want to know the current directory, the keyword is pwd. It's an alias with the Unix convention, but you can also current location. I believe the full I forgot what's the full command name, but what you can do is help pwd. That will tell you the full command name. So the full command name is get location. So you see, so clear pwd shows you the current path, which is ergo emacs. Or you can see you can say get location. Oh, get local, get location, get location. You see, it's the same thing. And if you want to find all the aliases of this command, commit, that's what it's called, you do get alias or gal, then definition, then you say get location. Okay, then it will tell you all the aliases for this command, get location, which you have gl and pwd. So you see, gl, pwd, they are the same thing. Okay, so anyway, that's a digression. So we are in this directory. That's what I'm trying to say. So we are in this directory. Now let's use PowerShell to do find and replace for the 2,500 files in this directory recursively. Okay, so how do you do that? Okay, the recurse, and like before, we want include star HTML. That's a glob match. That means all files ending in the name HTML. And we want to pivot to, okay, so we did this yesterday, but I'm still pretty newish to PowerShell. So let's code it here in Emacs. So PowerShell, okay, put it here. So start. This is XAH PowerShell mod. So it lets you edit PowerShell code. Very nice, convenient, and you can, of course, XAH PowerShell mod you can buy. You can find it on the web. Support me, okay? So, and it's open source, by the way. Okay, so now let's do so find replace code in PowerShell. How do you do it? So you pipe it to for each, okay? The percentage sign means it's a shortcut for each, okay? So for example, let me show you. GAL, get alias. GAL is the alias for get alias. So you say definition, then you say for each object. Then you can see, you see percentage sign is an alias for each object. It's a very convenient short. So that's what that is. So let's magnify. So that's so now you pipe it for each of the HTML file. You want to GC. GC means get content. Okay, the full name is get content. I'm just going to use abbreviations because it's more convenient. So get content $_ that means the current, the current file. So get content $_ let's put them in a parenthesis. Then you say replace. Replace is the operator for string. So then this is a find string, and you put replace string here. Okay, so the find string is going to be Haskell. Okay, the replace string is gonna be elisp. Okay, so get content, all the content, and do a replace operation, replace Haskell by elisp. Okay, then you need to, so once you get the content, you do the replacement, you need to write back to the file. So now we pipe it to out file. Out file is the command that writes to file. So out file, so help out file. So PowerShell has, just like man, just like in Unix, you man something. There's a online documentation. So here's the online documentation for out file. You press enter, so magnify. Let's go back. So out file sends output to file. We want UTF-8 encoding. We want, let me just do it. Okay, let me just do it quickly. No new lines, and confirm width. Okay, width is one of the important thing, I guess. Okay, that doesn't matter. Let's do this. Okay, so write output to file, and what's the file path? So you do So you do $_ that's a current file, and you want to dot full name. So PowerShell, they work by object. Everything in PowerShell is a .NET object. You see, when you do this kind of thing, it shows, it lists all the files. It's actually object, but when it displays, it turns them into a string. That's why that's how it becomes like string like that. So this is unlike Unix, where everything is just string. So in PowerShell, everything is actually .NET object. So right now we output to file. We want to write to file, the current file name, then dot full name. What's a dot full name? Because remember, because it's an object, so object has methods and properties. Okay, so full name is one of the property. Okay, I'm not going to go into details, but if you want to know, I have a full PowerShell tutorial. You can learn all about, for example, object type. What's an object? What's an object type? How do you find the properties? How do you find the methods? Okay, so just search for XahTV PowerShell tutorial. You'll learn the details. Okay, so back to here, find replace code. So I believe that's it. Okay, so but I'm not sure because once you run this command, it's actually going to do the find, replace, and write to file. So, but I want, this is my website, so I want to be careful. So I want to say dash what if. Okay, so the what if thing means don't do it, just show what happens. Okay, so this is the code, copy it back to PowerShell, paste it. Now pray to God this works. Do it. Okay, fantastic. Seems like it's working. Okay. Okay, so it's actually doing the find and replace on all files out there. You can see, so you see, it's actually trying to do the find replace on 2,500 files. You see, what if performing the operation output to file on target this path, it's doing find replace on all these files. And yeah, so if I remove the what if, it's going to actually do it. But this is not a good, we need, if we are actually going to write a find and replace script, this script needs modification, because you don't want to actually do the replacement on every file. You only want to do it on those files that actually contains the word Haskell. Okay, but this would work, because if the file doesn't contain Haskell, it's just the same. You're just writing the same file to itself. But it's inefficient. So if we really want to improve it, we need to let's think about how we're gonna improve it. So if we really want to improve it, let's let me try a little bit. Today, mostly we are going to try. We are going to code Wolfram language, so it's gonna take a while. So let's don't spend too much time here. Comments. Oh, Ztron crazy. Good morning. So many. So questions, ask me. Okay, tag me. So Disney's, how do you force yourself to do stuff when you don't feel like doing it? Do you have some secret technique that helps you focus on the current task, even if you don't feel like working on it? Okay, that's a different topic. Okay, that's not programming, but that's essentially about personality, which is okay. We are digressing, but basically, that's about a very general topic of how do you focus your personality and habits. Okay, basically, mostly interest is the most important thing. Okay, if you have an interest, a desire for certain things, you will always just do it. You don't need someone to tell you, oh, you gotta study, you gotta do something. You don't need, because there's a strong interest. So for nerds, for many of us, it's programming. We just have to do programming. For me, there was also mathematics and sex, okay, pornography. Okay, so anyway, but then you read about business people, 7 habits for successful people. Most, yeah, you can try to read those, but I'm old, I'm too old to. So anyway, so interest is the most interesting thing. But then you have the question: how do you get the interest? That depends on you. That depends on lots of reasons. Depending on your personality, depends on your DNA. Depends on your environment, your parents, how you grew up. For example, a lot mathematicians, engineers, physicists, or programmers, their dad is also some kind of programmer or engineer. So you have your family. So anyway, so interest, how do you get those interests? And also depends on what you want to do. Do you really, for example, lawyers, many successful people, lawyers, businessmen, politicians, politicians, they don't want, they have no interest, they have no desire, they don't want, had to have an interest in programming. If their son is learning programming, they're gonna stop it. They're gonna try. So there's also depending on what you actually desire. But then you have the issue of then there's a question. So if you are interested in particular thing, but right now, for whatever reasons, you don't have, you don't seem to be able to get yourself into, to do that every day. How do you solve the problem? Well, social engineer. So yeah, okay, social. Yeah. So you try to hang around with people who you think you like, who are your idols. So like me, okay, you watch my videos, you will learn more about coding. You'll maybe start to get interested in. Fascinating. Okay. Anyway, digression. Okay. So let's back to this. So we are writing a find and replace script in PowerShell, and right now we are successful, but the code is not efficient. So we want to modify it by first of all doing a grep. So you want to find the files that contains the word first, then do the find and replace on those files, then write to file. Okay. So anyway, I'm not going to write it because today I want to write a Wolfram language code. So show today's talk show. Okay, that's PowerShell code. So we demonstrated elisp, we demonstrated PowerShell. Let me demonstrate Golang. Okay, so I'm just trying to quickly demonstrate some of the okay. So here is a script. What's going on? It takes so long. So here is a script in Golang. This script is 150 lines of code. This is Golang, and this will do find and replace. So how does it work? So I wrote this in 2019. Wow, okay. I'm thinking it must be earlier. Oh, this is a 2019 version. I must have written this earlier. So if you want the code, you can go to my website, just search for XahTV Golang find and replace. So here's a code, okay? And I tell you what's a feature. So let's demonstrate. Let's shut up and demonstrate, okay? So here is the input. So what directory you want to do find replace, that one. What kind of file name, okay, .html, $, that's HTML files. Write to file, true. Okay, let's change it to false. I don't want to write to file because this is my website. Backup, true. Backup suffix, okay, that. And to skip, so of course you can skip certain directories. So you have this feature in this code. So there are certain directories you can, for example, .git. If a directory path matches .git, that means skip. You can add, you can add more here. So here is a list of files. I mean, sometimes you want to do find replace only on very specific set of files, not the whole directory. So you can put that here. If you put that here, you can, for example, let me show you. Okay, so elisp. Let's say I want to find replace these files only. Okay, not any other. So copy the file path. That's the elisp command. You can see copy current. You see that's my command. Copy file path. You can find the code on my website. So suppose you only want to find those files. Okay, so let's paste the path here. And look and watch this powerful command. Okay, I press the 3 keys, ding ding, and it becomes that. Each one becomes a string, and with a comma at the end. So this is the Golang syntax for a list of strings. Okay, in a slice, in an array. Okay, so now, for example, let's format it. Okay, so I'm okay. So let's go format. Okay, go format it. Okay, now it looks, you got indentation. So yeah, okay, so you got list of files, but actually in this, we want to do the find replace on all directories. So here is the find replace pair. You have the find string and replace string, okay? And then rest of it is the actual code. So let's run it. Okay, so write to file false. Okay, run it. And that command is run current file. Okay, that's a Emacs command. So here is the output. So this version in Golang is simpler. Remember in the elisp version, it also prints out the actual occurrences. But for the Golang version, I only print out the changed files. So there are these files that changed. So so you can, but actually write to file is false. So anyway, that's a demonstration of the Golang script for find replace. Okay, so close it. Let's change it back to true. Okay, close it. So we demonstrated PowerShell, Golang. Let's do a Python one. Okay, so Python. Okay, so I have written, because I do find replace for the past like 20 years every day on thousands of files. So over the past 20 years, I've written many find replace scripts in different languages. So here is a Python 3. Okay, there's a regular expression version and there's a plain text version. So let's open the plain text version. So here's a Python 3 code for find and replace. So again, you can specify a list of files and directory. Okay, so the directory needs to change. Okay, so the directory needs to be that. Okay, so here is the that's a directory. So comment that out. Input the then, and again in the Python version you can specify a level, the depth of the directory. Okay, so let's say just leave it. So regular expressions for the file name. Okay, print file name when no change, false. Backup file name extension. Okay, do backup, true. Okay, then what do you want to find? Okay, we want to find Haskell, the word Haskell by elisp. Okay, make sure the write to file is false. Okay, so because I don't want to screw up my website. Where is the write to file option? Do backup file, print file name when no change, file name. Wait. I don't have a write to file option. Okay. Yeah, so if we comment this out, then it will not write to file. So this script began in 2006, around there. Okay, so this Python script, because in 2006 that's when I started to learn Python. So output file open. So wait, let me make sure. I haven't coded Python for a long time. Once I started to use Emacs, Lisp, and Golang, I don't use the Python script anymore. So let's check. File name request, print file when no change, backup file name, backup this. So there's no write to file option. So okay, so you just need to change the code. So this function, replace string in file number. Okay, first of all, you replace them, you get the content and do the replacement, then you write to file. So let's just comment them all out. Okay, that should be it. Let's just run it. Okay, there it is, your result. So Python, you see, it tells you how many occurrences for each file. So there's 3 occurrences in this file. Okay, so this is a Python 3 version of find and replace. Again, you can find the code by there. Okay, now let's revert this and okay, so find and replace in Python. Okay, now I have also a version in Perl. So in Perl, yeah. So but hold on a second, let's go back to TalkShow because I want to create the links here. So here's a Python version, and here's a Golang version. Copy it. So golang Python PowerShell, and we are going to demonstrate perl. Okay, so perl version .pl. So there it is. This is a perl version of find replace. Is it getting boring? So perl find replace, so it's also on my website. Copy the file path, paste it here. There it is. Golang Python perl. Okay, so let's run the code. Okay, so here is the perl code. Perl is the earliest. I wrote this in 2000. Okay, so directory. So let's find the directory. Copy the file path. So here's the file path. So we need to modify this. Okay, so comment that out. Input the path. Backup. Okay, so this script is 20 years old. I have not used this script for 15 years. So now it says backup to this directory. So it actually, back then I have a different concept of where do you put the backup. So normally you create a backup in the same directory of the file. But here, the idea is that you create the backup in a separate directory or in an entirely new directory. So I'm not sure. Let's see. So let's say XAH backup. I want to be careful because otherwise it's gonna override lots of my files. Okay. So also I'm not sure. Oh, if it doesn't exist, it will be created. Okay, this is a good quality of code. You see, you can just type any directory if it doesn't exist, even nested. Okay, even nested. So let's try nested. It'll just create it. Okay, so now here's a find and replace string. Okay, again, you can have multiple find replace strings. So we want to find Haskell. We want to replace by elisp. Okay, then you can have another pair and another. So that's all. Golang, Python, they all, my script all support that. So okay, so this is a find and replace pairs. Then do I want to use regular expression? No. Okay, so you just say 0 and skip large file size. So if you have some files that's few hundred megabytes, you can skip it. Okay, that's it. I haven't run perl code for 10 years, so this is gonna be interesting. Let's see. Wait, where does it say I don't want to actually write to file? I don't want actually to write to file. So there's no option that says don't write to file. So that means I have to comment out the write to file part. Do I make sense? So let me read the comments. I think is it good? Am I doing good? I've been talking a lot, but today I want to code Wolfram language. So shit. Okay, 12:38. I already talked for 40 minutes and we haven't begun to code Wolfram language yet. Okay, so anyway, so it doesn't matter. So interesting question. Okay, I'm curious about these two. Politicians want to program society. Social engineers switched to Golang recently. Never used Python again. Indeed, that's my sentiment as well. Golang is a better language in Python. It's superior in many ways, in almost every way. The only exception is that Golang, writing the same program in Golang, it would be about 1.5, about 0.5 more number of lines. So for example, in Python, something is 100 lines. In Golang, it will be 150 or 130, somewhere around there. Okay, so the multiplication factor is 1.5. So Golang is more, you need more code, mostly template code, especially Golang, because you need to write lots of this error checking code that you have to, because the language enforces it. Usually it's annoying. So Python is actually slightly higher level, but however, every other aspect, Golang is better than Python. Golang's libraries is far better than Python, the built-in libraries. Golang's documentation for the language and for the library is far better than Python. The Python fuck. Okay, they refuse to change, the Python people, The Golang is also easier to learn than Python, easier, because the syntax, the grammar is actually much fewer. Okay, simple. Golang is very simple, easier to learn than Python. Golang is also faster than Python, because Golang is considered low level in the class of C, C++. Okay, that's what they are designed for, Golang. While Python is more or less considered a scripting language, Python, Perl, Ruby, Bash, it's a high level scripting. But so Golang is much faster, 2 times, 3 times faster than Python. And Golang can be run as a script as well. So for example, we just did Golang find replace in Golang, but not like C or C++ or Java or C#. You have to compile it. Get a binary code, then you execute that. And that's I don't like low level languages. So Golang support the you can just run the code directly. So it's like a scripting language. Okay, so Golang faster than Python. Also, you can use it like a scripting language, no compile. You don't need to compile it. And Golang, just like C and C++, Golang, you can, if you want to, you can compile your code, get a binary block, your software, and you can sell it. Okay, you can send it to your friends, and your friends can run the code. Not for Python, Perl, Ruby, For Python, your friends, you send him your script, your friend needs to install Python. You need the Python engine, but not Golang. Golang can, just like C, can compile into a binary blob, and your friend can run. So Golang, in my opinion, is superior than Python in almost every way. So anyway, okay, so this is TypeScript. Let's go back to Golang. Okay, we were talking about Perl. Yeah, okay, so, Perl is kind of dead now. Okay, so let's comment out the write to script part. I don't remember Perl. So process file. So actually the indentation is fucking too long. Shit. This is 20 years old code. So what I want to do is the opening file and write to file. So here is the opening file part. Write out to file. If not open, die, error. Perl has these characteristics. They like to say die. They are the Unix phonetics idiots. They are they are into the Unix philosophy with lots of puns, and they think it's fun. So they say die. If something. If it doesn't work, then die, error opening file. So I guess I comment this out, make a backup, comment this out, comment this out, comment this out. Okay, I'm not even sure this will work because this is very old code. Let's just run it, okay? Let's hope it will not screw up my website. But before we do that, let's go to okay, let's git commit, okay? So we can kind of git status, okay, git add. Can we do that? Yeah, git add. Do it. Git commit. Okay, so I have committed my website. So in case the Perl screwed up my website, I can revert. Okay, back to the Perl script. Let's run the code, shall we? So ergo emac directory, replace Haskell by emac list. Let's run it. Let's see what happens. There it is, processing. Oh, there it is. So the Perl output, let's see. Oh, okay, so it actually, you see, so the Perl output is processing for each file. It's reading, processing, 2,500 files. Okay, processing and go. Let's go down. Okay, then it says 2 replacement made for this file. Okay, then processing, then 1 replacement made for this file. Okay, this is okay, so yeah, so there's lots of intermix. So then at the end it says total files changed. The following large files are skipped. Okay, there are several. Okay, MP4 movie files. Okay, Richard Stallman videos. So this, anyway, so that's a demonstration of find replace code in Perl. Okay, so let's comment, remove our changes to the file. So okay, that's demonstration of Perl code. Close it. Okay, now we are the main topic. How do you write a find replace in Wolfram language? The main topic. Let's go to talk show. Wait, my syntax coloring is screwed up. Why is that? Oh, I missed. Yeah, I fucked up. Yeah. Let's see. Okay. Yeah. So now the main show, writing a find replace script in Wolfram language. Okay. Okay, so how many people do I have? The paucity of my YouTube watchers. So let's see, how many people do I have watching? We need to go to concurrent viewers, 3. Okay, so now golang, Wolfram language. Okay, I have the Wolfram language here. Okay. So what do you need to do in order to write a find and replace script? Okay, let me show you. the main things you need to do for writing a find replace script. Okay, first of all, you need to walk a directory. Okay, you need to go through a directory and find recursively. Basically, we want to order subdirectories. So that's what you need to know how to do in a language. Okay, then open file, get content of the file. Okay, that's the second thing you need to do. Let's make them a list. Okay, then the third thing, to find and replace a given big string. Okay, that's what you need to do. Then you need to know how to write to a file. Okay, that's the showing browser. That's the 4 things you need to know in order to write a find and replace script. Okay, now let's see. I haven't done any text. I haven't done any text processing type of programming in Wolfram language. I've been coding Wolfram language for about 20 years, mostly 1993 to 2005 every day. So over 10 years. But mostly it's mathematics, visualization, geometry. It's not text processing like the shell scripts. So this is the first time I'm going to do text processing in Wolfram language. It would be interesting. That's why. So let's begin. 3 plus 2. Okay, let's magnify. Okay, so first of all, you need to walk a directory. I'm thinking, I don't know if I can finish this. It will take me 30 minutes to an hour. I mean, also because I'm doing, because I have to talk and explain. So I don't know if I can actually finish it. But but anyway, these are the things we need to find out how to do. Walk a directory recursively, open file, get file content, do find and replace of a given big string. Okay, string. Okay, so let's see string. First of all, let's see interesting things, string functions. Let's see. What? Wait, I don't get, why is that? Do I like cats? What kind of question is that? Oh, what? So let's list all the string functions first of all. So first of all, let's find out how do you replace a string in Wolfram language. So here is all the string functions. Okay, I'm not sure I'm doing well. Am I? Where's my drink? I need to get a drink. Ah, shit. Forgot to bring my drink. I need to finish this because I know other people, after the live stream, other people will, there are a few hundred people will find it interesting. They actually, okay, I need to focus on what am I going to do. So, gonna write the Wolfram language find string. Am I going to do it? Yes. Okay, let's do it. It might take 30 minutes or an hour. Okay, but let's do it. I need to get my drink. I need to, okay, let's let me get a drink and let's do it. Okay, I'll be back in 1 minute. Comments, guys, comments, chat. If you haven't already joined Xah Discord, interesting people, okay? And on the keyboard front, this is wait, you see that? Oh yeah. So this is expose. This is fantastic. I'm going to do a review of the expose natural. I mean the expose night keyboard. Expose is one of my favorite keyboard. You know, it's fantastic. And I'm also going to do a review of the new Kinesis that's coming up. Okay, back to code, I think. Back to code. Let's see, what is this? Discord. Turn it off. Okay, Wolfram language. Okay, Wolfram language. Now, first of all, let's see how do you find and replace strings. There it is, string replace, okay? String replace, so here's the documentation, and string replace, let's see, there are 3 related functions, okay? String replace, okay, let's do this, okay? So here are the functions we need. Let's see. Okay, so okay, so let's go to Emacs. So let's start show in browser. Let's start a Wolfram language mod. Okay, and so you are looking at XahTV Wolfram language mod. So I can code Wolfram language in Emacs. You can get the mod. Okay, so pay me. Okay, buy it. Go buy it. So right now we are trying to find okay, let's copy so we know what we're talking about. So Wolfram language, so this is okay, we need to do these things. Okay, so first of all, the replace string functions. Okay, so we copied. So the Wolfram language. Okay, I'm not going to explain what these things are, but these are the functions that's relevant. Okay. So these are the functions that's relevant. So press the key to go to the Wolfram documentation. Turn on JavaScript. Okay, so let's see. Do I need to let's magnify? Okay, so string repeat, we don't need repeat, so string repeat we don't need. String replace, okay, so string replace string, then a replacement pair, replace a string expression whenever it appears. Okay, that's what we need to do. So the syntax is big string, then you need a bunch of rules. Let's say big small. Okay, let's try that, if that work. Do it. Fantastic, you see. So that is a function we need. But there are, there's a lot of features. Let's keep reading. So you can also have a list of rules, list of replacement pairs. Okay, then you can have, then you can specify, just do the first n replacement. Then you can specify, then you can apply this to a list of strings, like thousands of files. You can do them in one shot. We are getting into the power of Wolfram language. I'm telling you, I've been talking about how Wolfram language is a magnitude superior than all out there, including any of Lisp, Clojure, Common Lisp, Scheme Lisp, including Perl, Python, Ruby, including Haskell, whatever, Erlang, golang, C#, C++, Java, Wolfram language is a magnitude beyond them as far as the high levelness. Because so we are talking about doing a find replace script. Okay, now I haven't coded text processing in Wolfram language before, but however I can tell you it's going to be one single line. Okay, one single line, not super long. It's just one single line of let's say within 200 characters. Okay, because you can already see it. You see, you can have a list of a pair, list of pairs for find and replace, just like my code. List of pairs, you can do them in one shot. But however, this one single function, you can also specify a list of sources. So here the first element will be 1000 files content. Okay. Yeah. Okay. So that's one function. Now there's another function. Let's see how this one. How is this one different? String replace list. Okay, give a list of the string obtained by replacing each. Okay, so this one is basically, what does this string replace return? Okay, so let's see. Okay, I think it just returns a bunch of history. Okay, let me show you. Okay, so so the goal here, I'm trying to write a find replace script in Wolfram language, but meanwhile, let me just kind of tutorial teach you about Wolfram language constructs. Okay, so right now we want to know what's the difference between string replace and this string replace list. Okay, so in general, string replace list is just to give you a history of the replacement. Let me see. I think so, okay, so you can have a list of rules. Okay, so wait, let's copy. So big replace small, and let's see. Let's say G. Let's say B to C, and let's say C to D. Let's see what happens. Okay. Okay, replace all B by C, then replace all C by D. Okay, so you can see it does not do them in kind of repetitive way, because if it does not do them in a sequential way, because if you do them, which is not desired, okay? So you see, you want to replace all B by C. You also want to replace all C by D. Now there are two, this is very interesting about find and replace, okay, because it happened to my code as well. You see, so if you give this replacement, you want to all occurrence of C replaced by D. However, if you run them C, you see the original screen does not contain any C. Let's magnify, okay? So you see the big string, it doesn't contain C. So you see, this is a result, which is the desired result. But however, if you do a typical, if you code it in typical way, you tend to do find and replace sequentially, for each pair of the find and replace. But if you do that, B becomes C, then C changed to D. So you will actually so let me show you what's going on. Okay, so maybe I can. Do I make sense? Okay, so let me know. Do I? So what the other way is recursion, basically. That's not desired. Okay. So essentially this is what you have, okay? So first of all, you do B to C, then the result you do a C to D, okay? So for example, let's run this. Hopefully it runs. You see, it becomes dig string, which is usually not what you want. Okay, so that's a little bit, this is a very nice touch. Wolfram language is fantastic in this kind of ways, in many these kind of ways. It does what you actually want. So anyway, so let's go back to what's the difference. Okay, I can explain. Okay, so what's the difference between the list? The list one just give you a what? Okay, for example, let's run them together. It returns a list. Okay, is that all? Okay, I think let's move on. Okay, because we have still a lot to do. Justin Scoffy, we are doing Wolfram language now. Which is a language for mathematics, but however, it's not. But today we are doing text processing, programming text processing in Wolfram language. You would be interested in math, okay? And, so much I can learn from you. Okay, F says, I can already see the appeal of Wolfram language, but as a mathematician, it's hard to get into. That's false. Okay, Wolfram language, you don't have to use it for math. It's not. It's actually, I would actually claim it's the easiest because there's no irregularity. Okay, you just learn a few, just like Lisp. Okay, Wolfram language is a branch. You could say it's a branch of Lisp and APL. So there's no irregularity. You just learn a simple few handful principles and you know the entire language. Like we talked about before, Python versus Perl. Which one is easier to learn? Python versus Golang. Which one is easier to learn? Golang is much easier. Why? Because it's very simple. There's only few 10, 20 constructs. Then you know the entirety of all the language. Meanwhile, Python, you have lots of exceptions. The irregularities, like list comprehension. Then it's a new syntax, a little language within list comprehension. Then some of them are, then in Python, some are functions, some are methods. Then you have to learn objects. There's a lot. inconsistency. Okay, yeah, I mean they they don't call it inconsistency as well as irregularity. In vast majority of industrial languages, it's their syntax and semantics is ad hoc and irregular. For example, C, C++, Java, including Java, C, C++, Java, JavaScript, C#, all these, essentially Perl, especially Perl, they, the syntax is irregular. Like there's no one single principle. You have to learn, for loop, while loop. They are different. They have different syntax. Then you have for each iterators, which is another syntax. It's like that. Print, this is like the whole syntax. You have to every construct in a language is a new syntax. Okay, if statement versus if expression, entirely new. Yeah, it's like so you have to learn each one and every one. But on the other hand, Lisp, Lisp family of languages, Clojure, Scheme, Racket, Emacs Lisp, including Mathematica, it's one syntax for all. For example, in Lisp, parentheses, that's all you need to know. A function, parenthesis, a function, argument. Every code, source code in Lisp is like that. Okay, you don't have to learn special syntax. So that's one of the attraction of Lisp. Very simple syntax. Same. What's another example of such a language? APL. Okay, APL. Just look up. Okay. So APL and TCL maybe. Okay, I'm not too familiar with TCL, but anyway, my point is that in the syntax design of programming languages, there is you could say there is one philosophy where you only have a handful of very simple constructs. The entire language's syntax is based on that. You don't have to learn extra. Okay, so Lisp, Mathematica, Wolfram language, APL is like that. Okay. On the other hand, you have syntax design. You have like C style, C Java, C++, Java, JavaScript, Perl, Python, including Python. They almost every construct is a it has its own syntax. So about Wolfram language, I would say it's actually easy to learn. However, you have the perception it's hard. Well, only because you are familiar with C style, because C is a virus. It spread to all languages, to Golang, to Rust. It basically it's kind of the conventional syntax, so everyone get used to it. That's why I say Unix and C is like a criminal in programming industry. They are like viruses. They spread bad ideas all over because they are free, because they are the fastest. Okay, they use this kind of tactics. Half intentionally, half innocently. So basically, they have these qualities. They push, they spread. Like drugs, like a virus, to all the entire programming industry. So today, for most people, when they see languages, C, C++, C#, Java, Python, Ruby, Perl, they think, oh, that's normal. That's how things should be. Then when they see Mathematica, Wolfram language, Lisp, they think, oh, that's weird. That's difficult. Actually, it's a reverse. You think it's weird only because all the people get used to the bad concept of C. Okay, C. That's why I truly despise the C and Unix. Okay, so back to Wolfram language. So I need to finish. So we are continue coding the find and replace script. Talk, guys. Are you still here? How many people? 4 people. Okay, talk says something. So let's continue. Let's push on. Let's finish the find and replace script in Wolfram language. Okay, okay. So we know how to do find string, find and replace string now. But however, does the find replace string do regular expressions? That's what I want to know. But anyway, that's not important today. What is string expression? So where is the regular expression? You know, there is regular expression, but I don't know. It's one of these. Let's go to let's search the web. Okay, Wolfram language regular expressions. Okay, so that's what you have to do. Yeah, so XAH Wolfram language mod. So you have you know, press the tab. REGU, okay, press tab, you have completion, okay, regular expression. Okay, so here is the regular expression in Wolfram language. Okay, that's how you do it. Okay, so here this represent regex, for example, .html. For example, the file path ending in HTML would be that. Okay, so that's a regular expression in Wolfram language. Now we need to know how do you traverse a directory. Okay, let's see. Okay, let's try the find and replace string. Let's try the regular expression. Let's remove the complexity. Okay, let's do this. So now let's use a regular expression here. So okay, so let's say file name.html. Now we want to use regular expression to replace it by, okay, let's get fancy with the regex. Okay, so anything not a literal dot, one or more. So that represent the file name. Oh, actually, let's just do A to Z. Okay, A to Z with underscore and dash. Okay, so one or more, then dot HTML, not a plus. Okay, then replace it by the last capture dot WL, Wolfram language. Okay, Wolfram language actually it's dot M. Okay, so let's try this. Okay, so you see, I think it'll work. Do it. Okay, so yeah, so this needs to be // I think. Okay, that doesn't work. So the capture pattern, so you need to find out how do you represent the capture. So you see, the regular expression in Wolfram language is actually generalized. Okay, so it's not just you know, it's actually more powerful. So how do you do capture? How do you represent the captured pattern? Okay, oh, G there. Within a regular expression string, \gn represent the substring matched by the nth parenthesized. Okay, so here it is. So let me show you. So we want to replace by another regular expression. Let me copy it so you can see what we are changing. Okay, so we use string replace on this string file name.html and use regular expression that and to replace by that. Okay, let's see how if that works. Okay, not incorrect, so it's not correct. So how do you string match? How do you replace string with regular expression? String replace. So string replace. So is there an example where they use regular expressions? Oh, there it is. So here is an example of string replaced with regular expressions. But however, the replacement string, we need an example where the replaced string contains a captured pattern. Let's see. Let's try that. Oh, double slash, I think. What's wrong? Click. String expression, regular expression. Okay, so this is... Okay, I don't know. So let's go to tutorials. Okay, we are kind of stagnate. We stuck here. Character range, regular expression. Oh, there it is. String cases. Wait. Okay, so \\1. Right. Okay, so \\. You need. I think you need 2 backslash. Why is it? No. Oh, $sign. Oh yeah, okay, $sign. That's right. So this should be a $sign instead. Okay, so I think I know what's going on. So there it is. That worked. Okay, so let's modify this. So let me show you what's the proper. So here is the proper code. So you just, you have a big text here. Then you use a regular expression. Then the replace string is just a simple string with $sign representing the capture. Fantastic. Okay, fantastic. So that's how you do regular expression in Okay, so we got that. Okay, so regular expression. Okay, next we want to know, so now we know how to do find and replace. Next we need to know how do you open a file. Okay, so let's go Wolfram language, open file. Okay, okay, so here is the Wolfram language help documentation. Read string, write string, read line. Okay, so files. Okay, read string, write string. Okay, read string and file name. Okay, let's try that. Okay, restring a file path. Okay. Okay, that's a long file path. Let's see if that works. Fantastic. Okay, so this is a file content. This is how you read a string in Wolfram language. Read string. But now you can see there's some Unicode problem because I have a Unicode. So you need to specify the file content is encoded in Unicode. So let's see if there's options for read string. Okay, it's kind of long, so let's say options, read string, time constraint infinity. Okay, there's no option about reading them as Unicode UTF-8. It's okay, so that's a issue we need to actually, it's critical, we need to solve. You know, we can kind of skip this because, you know, you might think, oh, most of the files, source code is just ASCII. Not today. You know, not today. Today you have lots of emojis, you know, in anywhere, or arrows, you know, emojis or arrows, you know, in anywhere in your source code. So you want to make sure that when you open a file, you are using the correct encoding. Otherwise, Chinese characters, Russian characters, they all got screwed up. So here is how you write to file. Okay, let's copy that, write to file. Okay, so here's how you write to file path and string. But how do you deal with encoding? Okay, file. File function is a symbolic representation of a location in a local file system. Okay, now does this have encoding option, creation date, last access date, byte count, raw byte count, permission, device, UID, GID, SID, owner name. So it represents a file in the Unix tradition of metadata. Okay, these are the Unix tradition of metadata. But I don't see any encoding. We need to okay, file operations. Let's see, file operations. Copy file, rename file, delete, convert, file format, file byte count. Okay. So we don't know how to, how to make sure the encoding is correct. Okay, but let's worry about that later. Now we run into directory, which is one of the things we need to do. We need to know how do you traverse the directory. Okay, so here are I think here will lead us to it. Directory. So how to traverse a directory. So directory Q is true or false. Okay. Directory directory operation on file names, file operations, directories and directory operations. Okay, so current kernel directory, notebook directory, reset directory, parent directory. Print out the directory part of a full name. Okay, directory part of the name, file name join, file name split. Okay, so we need to know, given a directory, we need to list all the subdirectories in it. Set directory. Okay, so create, rename, copy, delete. So manipulating files and directories. God, Wolfram language has 6,000 functions. Copy file, rename, delete, file byte count, file date, create directory, rename directory. Maybe you could use file name something. Oh, yeah, okay, so that's a good idea. File names. Yeah. Great suggestion, but yeah, let me look around a little bit more. So read list, byte, record list, word separator. So I'm sure your idea works. So let's see, file name. Okay, file name. Okay, so let's say let's give it the Emac path. Okay, so Emac, so just like before, then we use a asterisk. Okay, that will work, I think. Oh, okay, so actually in list all files in the current working directory. List all files in your directory. Okay, that's the syntax. Okay, so you need to say okay, I think that's what? Why is it so you need to look at examples and documentation. File names can be given as literal strings or regular expression or string expression. Okay, let's try this. You know, what is a directory is actually, you know, I don't want it to list all of a sudden all my, you know, all the files on my disk. Oh, okay, I forgot the S. Okay, so yeah, that's right. Oh, fantastic, fantastic. There we have it. So there it is, 2,500 files. Okay. Well, 1,000 files there in this directory. So yeah, fantastic. So file names all. So this gives you a list. Let's see if it does actually recursive. Okay, I think it does. No, okay, it actually does not recurse. Wait, but if you put a asterisk, does it? Then it recurses. Okay, then okay, fantastic. This is, yeah. So you include the Emacs directory. You include also the, you know, the miscellaneous. Yeah, you include all. So this is fantastic. This is what we want. Okay, you see. Okay, so let's write it down. Okay. This is how you list all files in a dir, including subdirs. Okay. Now there are maybe better ways. I mean, you know, usually when you code, you want to find the best way. I mean, you know, the idiom or whatever you call it, you know, the proper way to do it. But anyway, we know this works for our purposes. Okay, let's, you know, we want to get this to work. So this works. This will list all directories and subdirectories, you know, return a list. You know, one of the great things about Wolfram language is that just like Lisp, everything is based on list. Okay, so it just returns a whole list. Then you can use any of the map function to just apply functions to everything. So let's put this together. Okay, we are closer. Okay, so this is how you read the file. Then write file. Let's put it down. Okay, so, and this is how you do find replace, and this is how you do find replace with a regular expression, and you want to do, how do you do write to file? Okay, so we need to, yeah, write to file. But let's skip that first. Let's try to put this together. Let's see if we can. Whoops. Let's see if we can put this together. Okay, so yeah, this is silly. Wait. So we want to. So we got these file names. We got all files. For each file, we want to read the string. Okay, so read the string. So each one, so we want to map. Okay, so I'm gonna write this quickly. So function, so that means a pure function. Okay, so you want to read string of whatever argument there, and you want to map you want to map this into all file names. Okay, so for each file name, so this return a list, you want to read the string. Then so you got a list of all the contents. Okay, so hold on a second. So actually, let's say, you know, I'm thinking, I'm wondering, you know, I'm dithering whether I should do it in a short syntax, which is idiomatic, which is, you know, the more efficient way to code in Wolfram language, or should I use a more standard notation so that everyone can actually understand what we are doing? Yeah, so the best thing is actually use the standard notation so everyone understand what we are doing. So okay, so let's okay, so let's do this. Okay, file name. Okay, let's write them in full. So here's a function and takes one argument, file name, and here's the expression. The expression will be read string. Okay, read string the file name, and remove that. Okay, so this is easy to understand. This is we are writing this is a lambda. Okay, this is what you call a lambda in Python, in other languages. So function, one argument, file name, and the file, and you read the string. Okay, actually it should return two things. Okay, I wanted to return two things. One thing is the file name and a list, return a list. Okay, the first part is the file name, the second part is the actual content. Okay, let's say content. Okay, let's do this. Okay, CT just means a content function. I mean, it doesn't mean anything. It just wraps a CT word around it. Why do I want to do that? Because later on it's easier to anyway. So you want to map this function to this. So how do you do that? The normal way is you do this way. Okay, so here is your function map takes two arguments. Okay, three arguments. So this is the first argument. The second argument is the list here. God, I'm going all over the place. So let me do this. Okay, read it. Okay, here is a function. Okay, that's easier. So files. Okay, files equals to okay, so that's easier. So read it is a function. Then we can read it, files, and we don't. Okay, so that's what we do. Okay, so we read the file. So then we need to do replacement. Okay, so actually there's a lot more to do. So we read it. You know, I'm writing it right now in a very verbose way. You know, that's not normally how I do it. But we you know, this is better for explanation. Okay, so now you assign to a variable file name and content, which is a list. Each element is a list of two things. The first part is the file name. The second part is the content of the file. Okay, then again you want to map again. Okay, so let's do this. Okay, so this is let's say 2. Okay, file name and contents 2. So what you do is you map to that, and this time you want to do a replacement. Okay, let's write do replace. Okay, do replace is a function. Okay, let's write okay, do replacement is a function. The function takes one argument, content. Okay, so okay, and what do you do to the content? You replace the content. Okay, so like that. This time you want to replace okay, so here's a content. Let's say big text. Okay, content. Okay, content. Then you want to replace the word Haskell by elisp. Okay, is that clear? So here is another function to replace. It takes a giant text and replace Haskell by emaglisp. Okay, then you got a new content. Okay, new file name and content. So we map the do replace command. So actually you need to, so here is how you write it. Okay, you need another function. Let me write this in the most clear way so people can understand. But you know, I want to say, you know, because it looks, you know, big, but normally if I code it, you don't have all this code. You know, it's very compact. But however, it takes a lot of time to explain what they are. So let's do in the most verbose way. So again, you call a map to and return a new content, and this time the function takes one argument. Okay, the function takes one argument, right? The argument is the path and content, right? The argument is basically a list of two items. The first part is the file path. The second part is the content of it. Okay, so you write a function that takes that argument. Then you can create a module, which is a local function. Let me show you what we are doing. Okay, so the first part again, remember, so let me show you. Okay, so here's a file path. File path will be that one. Okay, so that means, remember the, okay, so do I make sense? Okay, so let me do this. So remember, we are calling the function map. Okay, the map takes two arguments, and this is our first argument, which should be a function. The second argument is a list. Okay, so that's what it is doing. Now this function we are creating, it will take one argument. Remember, each of the file name and content is a element, is a list of two things. The first part is the file path, second part is the content. So this function takes one argument, that list. Now we want to, inside here we use a module. A module is like Lisp's let. It's a local variable. It's like let. Okay, so the module, what? Okay, the module will, you know, let me, the module. Okay, so we need some kind of a formatting to make this easy to see. But I hope you are seeing it. So the module, the let, you know, local variable, the path and content. Okay, so the content will be, you see, the path will be the first element, the content will be second element. Okay, and now we call the do replace function. So we call the do replace function on it, and it should be content, right? So we call the do replace and give it the argument of the content, right? So it returns the new content. So however, the whole return, we want to return like this. Okay, so here this is the return value, the return value we actually want. So do I make sense? Yeah, so the heart of this function is just this part. It returns a new two element. The first part is the same path. The second part is the new content. Okay, so that gives us the file name and content. Now we just need to write the new content back to the file path. Do I make sense, guys? Okay, this is close to 2 hours. Let's run it. Okay, let's just run the code. Okay, this is too long. I don't want that. Okay, so let's do that. Let's do that. Let's do that. And let's just make them one line. You know, let me show you. Okay, so okay, Wolfram language. Read it is a function. Files is a list of all files, 2,500 files. File name and content, so it's gonna return a giant list, and with every content of the file. Okay, some error. Cannot open that because read string file name. Read string file name. Then files, okay, then file name and content. Read it function apply to files. So open read cannot open. Okay, let's do some modification. Let's path. Let's just say path. Okay, path, and let's remove that. Okay, so read string file names, and this directory too big. Let's try some other smaller directory that doesn't have 1 million files. Okay, current frequency data files, EX logo. Okay, EX key binding. Okay, let's try this file, this directory. Okay. So in this directory, so let's okay, so actually let's show the empty. What? Why is it empty? But that works. But why is that the other one empty? Show all files. Why is that empty? I don't get it. That also works. But then what? Okay, now it works. Turns out you don't actually need the asterisk. Okay, so you don't need the asterisk. So you see this works. Okay, so this works. Now let's try those code. Okay, so first of all, it lists the files, then file name and content, map, read it, and files. Oh, there's a mistake. Yeah, read string path. Okay, start over. There is the content. Okay, these are image files. That's why. Okay, so yeah. Yeah, so these are image files. That's why you get this huge thing. Okay, so we don't want that. You know, those are PNG files. So now I want to only limit to HTML. So let's do this. Maybe it'll work. No, the asterisk doesn't work. Yeah, so right now we need to again filter. Okay, this is getting and I'm getting tired. I need to filter. So that lots of let's look at file names. Okay, file name, there must be some way to filter it. Form 1, form 2. Okay, form. Okay, so file name, let's try form. There it is. Okay, that's how you do it. Form. Okay, so that's how you do it. This is how you read the file. So that's how you read all HTML files only. Okay, yeah. So here, it's never mind what I'm doing. Okay, I'm just doing some cleanup. So here is the so here we got the HTML files only. It turns out there's only one HTML file in that directory, which is good. Then we map it. Okay, let's try it again. Fantastic! It contains the content of that file. You know, let me show you what that file is. Okay, so we open a directory. So this is the this is the HTML file. We open it. You can see that's the content showing browser. This is a very old article, 2005, when I was trying to do Unicode in Emacs. So this is Unicode in Mac Emacs and text editor year 2005. Okay, so that's that. So in Wolfram language, you know, it's actually showing the content. That's exactly what we want. So each element is, the first element is the file path. The second element is the entire content of the file. Okay. Now let's replace the word. Let's replace the word year 2005 by year. You know, let's say replaced by something else. So now we need to so to replace is a file name is a, so we replace that word by year today. Okay, by that, by year 2021. So here is a function. So let's do this. So those are functions. Yeah, so the first two are functions. Then this is a list of files, and this file and contents. Then new file and contents. Let's see. Yeah, so this is I believe content is spelled incorrectly. So let's fix that. Where is it? Oh, okay. So let's just say big text. So path and big text. Okay, so write file, we don't care. We don't know how to write file yet. So that. Okay, so here's the code. Let's see if we can make it pretty. No. Okay, so wait. Do it. So did it actually make the change? Let's look at the year 2000 in the title. So year 2005. No, the title, wait. Yeah, so here's a new, there it is. It changed, you see, year 2021. Year 2021. You know, the title, the HTML title and the HTML H1. So far the code here worked. Okay, so these few lines of code. Now the next step to do is to actually write to the file. Okay, but I think I'm tired, and let's it be that today. We did this for 2 hours now. Okay. Yeah. Okay. So yeah. Okay. So the next step we have to do is to write the file. Basically, we are almost done. But so here is the Wolfram code is basically this, okay, and plus the write file step. So basically the Wolfram code, let's delete that, is this part, okay, just how you do find and replace to a file. Now again, like I said before, I wrote this in the most beginner way, so you can easily see all the code is of the function and format. So but there's much better shortcuts, which is typically after a while that's how you code Wolfram language. So let me show you that version. Okay, so let's copy it. Let's do it here. So let me show you how you do that. So instead of this, okay, let me show you one by one. So you don't do that. You write, okay, path, okay, read string. You'll see in a moment. Okay. Okay, that's it. So this line is equivalent to that line. Okay, now this line is equivalent to let me write it. Okay, so again, function, remove that, so just string replace. Okay, okay, so this line is equivalent to this line. Okay, much more easier to read. So let's remove the top one, remove that one. Okay, so here we have two functions. Okay, that's how you write, that's how you do it. And this line, again, this line, file names. Okay, this line, no change. This line, oops, wait. this line, okay, can be written okay, like that. Okay, so these two lines are equivalent. Okay, shortcuts. So remove that, and this line very long. Okay, so now this line, how do you rewrite it? Let me show you. Okay, so you don't need all these, you know, too long. Okay, so this line is equivalent to this line. Okay, so you know, that's how, I mean, that's the power of what's so called in Lisp. This is called meta expression. Okay, in Lisp you have symbolic expression, which is SEXP. You know, that's a short, in short, symbolic expression, which is full of parentheses. Then you have what's called meta expression, which in Lisp almost never happened, but it was in the concept of the original Lisp inventor McCarthy. So, but in Wolfram language, it actually happened, implemented that. So here you might call this symbolic expression, but here is the what this would call meta expression. Now in Wolfram language, this you don't call that. You kind of call them full form and the standard, you know, standard form. Anyway, so my point, you know, what I'm showing is that you see. Okay, so let's compare. Okay, so let me make sure. Let's compare before and after. Okay, so before, your code looks like that. Okay, that's before, and after, your code looks like that. Okay, and we can try it. Let's try it and make sure we are correct. Yeah. So it's correct. It returns it did the find replace on the new content. Okay, so like I said before, this actually should be one single line. How do you do that? Let me show you. Okay, single line. It should be just one single line. You don't need all these, you know, I'm assigning them to variables and so on, so that it's easier to for beginners to understand. So for example, this is a read it function. We don't, you know, it happened once, so we don't wait. So just put it here, and this find and replace function, we don't need it because we only use it once. So remove it, put it here. Okay, and this the file function, only we use it once, so we don't need the whole thing there. Delete that. List the files, put it here. Okay, so now two lines. Okay, you don't need two lines. Okay, because this is only used once. Okay, so so we just remove that, put it here. Okay, so now it's just single line. Now this single line, you don't need why do you need to assign to a variable? So you don't even need to assign a variable. So this one single line. Okay, that's Wolfram language. I don't know if you can see it. That's Wolfram language mathematical code. Let's try it. Okay, let's try it. Do it. Okay, I got the function wrong in my editing process somewhere. Okay, so let's fix that. What is going on? String replace. Okay, so we shit. This is, this is bad for my demonstration because now you got an error. What is the error? Part specification is longer than depth of the object. Okay, part specification, which is here, which is longer in the depth. Oh, okay, so okay, so you need to separate them. So again, the map takes two functions. So here is our first function, which is this whole thing, and here is our second function. Okay, read string. So you don't even need that. So read string. Oh, okay. So I got, yeah. So I know what's going on. So yeah. So you got a mistake. I somehow made a mistake. Okay. So that should be the code. Let's do it again. Fantastic. You see, it works. And you see, in Wolfram language, it has the feature of auto format, so you don't need to, press tab or whatever. You make them generally you make them into one line. Okay, then you paste it here. Wolfram will automatic format it in a smart way. For example, you can see as you shrink, let's highlight it. Let's highlight this. As you shrink, the code focus on this. Okay, so let's make a copy. So remember, I copy this code, go to Wolfram notebook, new notebook, paste it, one single line. Now if your window is wide, then it's one single line. If your window is small, it formats in a sensible way. You see it with indentation and all that automatically. You see, you can widen, you see, in a semantic sensible way. Okay, so it's not, random placement of breaking lines or indentation. Okay, so here is the entire code for find and replace in Wolfram language. Okay, just this line, except we didn't write to file. So we need actually, how do we need to write to file, right? So we so we need to actually add another function so it actually write to file. Okay, but that's it for today. Maybe it could be shorter. Yeah, there's more ways to make it shorter because right now, let's see, where's our PowerShell. Okay, so let's see. The PowerShell is this, but it's not efficient. Okay, let's compare. Okay, let's do Wolfram language versus PowerShell, which is shorter. Okay, so let me do. Okay, so this is PowerShell. Okay, wait, open it, make it PowerShell mod. Yeah, okay, so XAH PowerShell mod. This is PowerShell. Now Wolfram language. So you want to be shorter? Okay, so let's let me do it. Okay, so let me do it. So yeah, so this whole thing, so this is just this single line. Okay, so yeah, we need the right file somewhere. Okay, so let's okay, so the map, first of all, you don't need a map. Okay, so you can let's see where I want it. So yeah, so you don't need map. all you have to do is that. So yeah, read of the map. So now we read of the, so that's what it looks like. And also this function, you know, our algorithm is actually very redundant because, you know, we actually created a list of each and every file content. You don't need to do that, okay? You know, we created a list of file content as a interim result. You don't need that. It's very inefficient, you know. So remove that, okay? So yeah, so so we don't actually need a map, so we just place the read function. Let me see how you do it, okay? Yeah, so here is a read function. Yeah, so read string is going to be removed, okay? Just read string, and you see we don't need that entire thing. So we read string of a file path, then do the replacement, okay? So we already, okay, so we don't need that. We don't need that shit. Okay, now it's much more simpler, okay? We don't need this shit either. So read string of a file path, then do the replacement for then you map it to, yeah, it's so simple now, okay? It's just now it's becoming very simple. So then so you map that. Yes, you have to map it then, but right string, okay? Let's put the right. Actually let's fix the script so it actually works. Also, you know, write to string. So write to string here. So that's what we need. The file path, that's right, the file path, there it is. The right string, so this is a function. Yeah. Okay, so that's it. That's that. Okay, so this is the final complete code for find and replace in Wolfram language. Can we try it? Yeah, let's try it. Now, okay, before we try it, let me just go over, make sure it's correct. Okay, so the argument, the right string, read string, takes a path. That's right. That's right. Okay, so I'm fairly certain this is correct. Okay, so let's copy that. Let's paste it here. If we run it, that file will be changed. Okay, in fact, all HTML files, but however, we limit it to this directory, so there's only one HTML file there. I don't want to change my whole directory. So, you know, just so, okay, so if you run it, that file will be changed. So let's run it. Done. Okay, so now let's open that file. Unicode. There it is, showing browser. Unicode in Emacs and Emacs text editor, year 2021. So we did change. So success. So now you see, now you compare, okay. Now you compare, okay, so we are comparing, you know, which one is the longer, okay, so yeah, so the PowerShell, okay, so let's do the comparison. Now the PowerShell here is not fair because you don't actually contain the full path. You need the full path, so let's change it. So yeah, so you need a full path, there it is. Then let's say, okay, then let's say Haskell to Emacs Lisp. Okay, so let's change this to Haskell and Emacs Lisp. Okay, so how many characters in Wolfram language? I need to compact. Okay, so hold on a second. Compact code, remove white spaces and so on. Okay, there it is. Now, okay, so where's the PowerShell? Oh, the PowerShell is on top. Right. Okay, so now how many characters are there? Count words. 142 characters. Okay, 142. Now how many PowerShell is there? You don't need the file. You don't need that. Oh, wait. What? You forgot the path. $133 characters. So PowerShell is 10 characters less. but let me reduce it further. Okay, you don't need how do I can I see if I can reduce it further? Okay, so yeah, the problem with Wolfram language is that you have these long names, write string, string replace, read string. Those are long names. Oh, in PowerShell, the full name is get child item. So get, instead of the proper name is get child item. So if we write this properly, if we write this in a way, you need to, send it to your work, so you have to write properly. Okay, still. So how many characters are there? 143. So compared to the Wolfram code, 142. Wolfram code is 1 character less. Okay, so PowerShell you can also remove the redundant spaces. Okay, anyway, so in the end, so you have the PowerShell code, then you have the Wolfram language code. Okay, they are kind of similar. Yeah, exactly. Count symbols, but that gets that's a proper way to judge how short is a programming code. But however, that's not popular because then you got the issue of you have to write a script to replace all the long function names and so on. That gets fairly complex and non-trivial. I mean, it's trivial, but it's actually tedious to do because Wolfram language has 6,000 functions. So anyway, yeah, a draw. Okay, now I'm not satisfied with a draw, so I'm thinking, is there can I actually make this simpler? Let's see, file names. I think that's about the best you can do. Okay, that's it for today. Thank you guys for watching. That's 2 hours. If you like my stuff, okay, donate, PayPal me, Patreon, buy my Emacs mods, Wolfram language mod, PowerShell language mod. It's all on my Emacs website. Buy my Emacs Lisp tutorial, and Wolfram language is free. Okay, I mentioned this many times. Just search for Wolfram script. Okay, you can actually run it. Let's see if I can actually run it. I don't have it installed. I have the but you can download it for free. Just search for. Okay. So I have a tutorial. I did several videos. Okay, so Wolfram language tutorial. Several past videos, and this one we did last week is very good. Okay, it's fantastic. It teaches you Wolfram language doing geometry, which is the main use for Wolfram language, not for shell scripting. I mean, this is this is the first time I'm doing text processing in Wolfram language. That's why I'm not familiar with this. But the traditional use of Wolfram language is engineering, physics, mathematics, sciences, chemistry, so I did a video last week, and several, okay, And the Wolfram language for free, you can download it. I show you how, several ways. If you buy Raspberry Pi, it's also free. It's come with it bundled. Or you can just download Wolfram Engine or Wolfram script. Okay, thank you guys. Bye. Fantastic. Okay, we shut down in 1 minute. I'm just cleaning up my code. Okay, so copy that. Go to talk show. Today's talk show. PowerShell. Paste it. Okay, then Wolfram language. Yeah. So after all this trouble, we reduced it to this final and correct version, one single line. Fantastic. Thank you guys for the for telling me to do it. I wasn't sure we gonna. Okay, so yeah, so do I okay, so first of all, copy that. Go to talk show, put it on my. Bye guys, bye. Put it here, so you can see this is the syntax coloring added. So you can see this is the final Wolfram language code in PowerShell. Okay, so the PowerShell, let's remove the first one. Okay, show it. Okay, add syntax coloring, show it. Then go back to the Wolfram language. Now the Wolfram language, we add some tutorials, so people can see how to read string. Okay, so for example, this is how you read a string, read a file. How do you do find replace? How do you do regular expression? And how do you, that covers it. Okay, so this is how you do that. Okay, and replace string. Okay, we don't need that. That search failed. Okay, wait, search failed. Bye guys, bye. No, this idiot, of course. Okay, this is the final page for today's talk show, and show the video part. I'm gonna upload it to my website. You can. So today's talk show notes, we demonstrated how to find replace in Emacs, Lisp, PowerShell, Golang, Python, Perl, and here's a PowerShell code, and here's how to do it in Wolfram language, and finally here's one single line. Fantastic bot. Good night.